Example 3. Given m of x equals -2 if x is strictly less than 1, 1 if x actually equals 1, and 0 if x is strictly greater than 1, I can see this piecewise function has 3 pieces. So all 3 pieces look like they'll be a constant function, except for that middle piece. It's actually just going to be a point because it's only defined for exactly one domain value, and that value is 1. So let's look at these 3 pieces. We'll call it the left, the middle, loosely call that the middle, and the right. So we will look like the constant function y equals -2 when x is strictly less than 1. So I'll pick a number that I like, less than 1. That would be 0. I would get -2 for y. Then I'll pick 1 because it is a boundary point. Even though it's not defined on this piece, if I did plug it in, I would get -2, but that is going to be a hole. Now in the middle, I'm going to be y equals 1, but I'm only defined in the middle at x equals 1. So this is just going to be a solid filled in circle, the point 1, 1. And then the right piece, I will look like the constant function y equals 0. So I'll pick the boundary point first. Even though I'm not equal to 1 in this piece, I'm going to designate where it begins with an open circle for a hole, and I would get 0, but that's a hole. And then I'll pick a nice number, number 2, for an x value, and I would get 0 again because that's how the function is defined on that piece. So putting this all together on the graph, we just have to be careful about where am I graphing which piece. So when x is strictly less than 1, I'm the constant -2, y equals -2. So at 0, -2, I have a point there. I need another point to construct a line, but it's going to be this hole that I put in my table at 1, -2, and then this is where I draw for all values less than 1 and indicate that I go on forever to -infinity with an arrow. And then I have the point 1, 1. That's our middle piece, and that's it. It's just that single point. And then I have the constant function of 0 that's on the x-axis because the equation of the x-axis is y equals 0. And then I could get another point to construct this line, and then I would extend the line to the right with an arrow on the end to indicate that I'm going on and on forever to infinity. Is M continuous on its domain? Well, let's look at it. Do we have to, as we trace this function, I'll get a different color here, as we trace this function, let's get a yellow, you have to lift up your pencil? Well, yeah, right here at 1, there's a hole and there's a gap. So it is not continuous on its domain. It is discontinuous. So the answer to that question is no.